All right, greetings everyone. Welcome to Cohort 4 on June 20th for Chapter 1 discussion. We're going to get to Chapter 1 discussion in 1 second, but I wanted to just show one area of development and something that people can explore, and then mention one thing about Math Learning Group. So first, in the equations page, there's a few sub-pages that might be interesting to explore. First, where we previously had the equation screenshots, so you could like mouse over equation 2.1 and click on the screenshot, we added the LaTeX. So this is just a plain text code that renders in Coda. Then there's some sub views that use Coda AI. So this explanations view, these prompts, basically just to show what it looks like in Coda AI, explain the LaTeX as if I'm not familiar. How would a high schooler be interested in this? What's some summary code? Where is this equation important? And can you explain the variables? It's not perfect, but it gets pretty far. Very cool. This is the explanations page. There's a philosophy page, just one column, but it's just bring up 10 philosophy questions. And a lot of these are like awesome discussion starting points. You know, what does divergence mean? All these things. And then also languages. So here's just a few languages, but we can add people's preferred languages. Just totally feel free to make a suggestion. We can add more AI columns. So we have to keep on exploring this because the LaTeX representation with plain text is really amenable to this kind of language model work. So just mention that. And then also someone in Cohort 4 is interested in the Math Learning Group. I think they're potentially interested in like a morning time UTC. But if somebody else is interested, then we can kind of get this going. So it could be in the Discord. But if anyone is interested to pick up with Math Learning Group, and basically just it can be an unrecorded session in the Discord, another hour to go over the equations. Sorry about that. So if anyone is interested, maybe just write a comment here and just say, here's some times I'd want to do this. Just basically like a math study time. And then let's just see if there's any specific options for what times people want to do such activities. So on either the AI or the Math Learning Group, does anyone have any just general thoughts or questions? Otherwise, we'll move to Chapter 1. All right, so let's head over to Chapter 1. Just right off the bat, before we get to the questions, it would be awesome if anyone could just share any of their reflections on Chapter 1. Just anything about their experience reading it, or what they felt it was like, or what stuck with them, or anything that kind of raised after they read Chapter 1. Go ahead, Andrew, and then anyone else.
Yeah. So I've had some familiarity with Active Inference for a while, so a lot of what I read already tracks for me. But that said, I'm curious about variational free energy is like a particular, it seems that Active Inference seems to be based on a particular form of Bayesian inference that it relies upon like this variational formulation. I'm more curious about that. I assume the textbook will get much more into what's specific to variational free energy as opposed to some other formulation of it. But yeah, that's something that I'm kind of still chewing on right now.
Thank you. Anyone else?
Yeah, I'd read chapter 1 a while ago, and I think I just dove deeper into it, knowing that we're looking for questions and stuff. But I really appreciated the video that you and Ollie did, so I watched that for the first time today, and I really appreciated the heads up to actually read ahead to chapter 10, which I'll do. Yeah, that looks good. For me, in this more in-depth reading, action really stuck out to me. So I went to the ontology to look at the definition of action. That's like central to my area. I'm in motor neuroscience, and I can relate to the idea that action has to have a goal and purpose. But I noted that in the ontology, that goal and purpose is not in the definitions. It's more of a general sort of behavioral definition. And then I started to think about, in our area, we also use inaction, so like action imagery and observational learning, which you're not really acting, you're watching somebody else. And so I posted that question about does action have to change the world? And what do we mean by that? Do we mean like I'm going to change the physical world that we all share, or am I actually sharing my internal, changing my internal model of the world through action? Yeah, so in summary, I really got hung up on this action terminology.
Cool. That those were some great things to explore. Anyone else with just any thought about chapter 1?
Yeah, I was familiar with the Bayesian brain hypothesis about like our mind is kind of a predictive mechanism, and yeah, but like this framework, the more I thought about it, the more I started seeing like these patterns around me, like thinking about the different things that I observe in that sense of active inference, like the action and the perception, and like specifically I saw it like in children's behavior, for example, like the ability to change their mind and their belief in contrast with like stubbornness. Sometimes when they're very stubborn and kind of like they will do whatever they can to change their reality, although they can't necessarily do so. But so it was very interesting just thinking about like various behavioral patterns that I see around me, and translate them into this framework.
Cool. Thank you. Yeah, Javier, and then anyone else.
I have a question about saliency, because I'm quite familiar with the definition of saliency in vision science, in which something is silent if the visual features involved are different from what you have in a neighbor. But I think that saliency has a much more general definition in active inference. So I'm quite interested to understand, how it is quantified and what its proper definition, its generalization, how it generalized, the very simple definition in vision science.
Cool.
Oh, for me, I'm a psychiatrist, so talking about Helmholtz, Freud, who invented the psychoanalytic theory, was influenced by Helmholtz. And as you can see in the chapter 1 and also at chapter 2, Helmholtz said that perception is an unconscious inference process, and which is quite interesting because so the psychoanalytic theories are based on the assumption that individuals make interrelationship based on their childhood memories and experiences, and based on the fact, I got quite curious about whether we can explain psychoanalytic theories based on active inference or other computational models that are based on these assumptions, or theories that are inspired by Helmholtz or other scientists who are also having similar points.
Cool. There's definitely some other people in the textbook group and around, so I hope that they can continue on this topic. Anyone else want like a general topic, or we can return to some of these mentioned points as well as some of the other asked questions?
Just I don't want to detract too much, but just in response to Young Hoon, and maybe you're already familiar with this, but the way I ended up at Active Inference was through the work of Mark Solms and neuropsychoanalysis. So I would strongly recommend checking him out. And he wrote a piece where he completely rewrites Freud's like early scientific paper using the terminology of active inference. I think it's great, and I'd be happy to explore the relationship between psychoanalysis and active inference, like more potentially within the confines of this group in the textbook.
Oh yeah, I heard about him, but I never actually read his papers, so I'll look it up. Thanks for bringing it up.
Sure.
I think you're muted, Daniel.
Ali, want to unmute and go for it, or?
Yeah, just wanted to mention Georg Nordhauf's work in relation to, psychoanalytic understanding of active inference. It's not completely in line with Mark Solms' line of research, but it provides an alternative path through some of the psychoanalytic ideas of active inference based on his own spatiotemporal philosophy of neuro.
Okay, cool. All right, well, let's just revisit some of these topics and then turn to the questions, but we're totally just chilling and whichever ways that people want to go, or anyone who wants to raise your hand, like, whatever comes to mind, let's just do it while we're here. Some of these, as with the many coats of paint idea, we're just gonna kind of give like a first or a few thoughts on, and we're going to be revisiting in the coming chapters, because like this is the topic. Chapter 1 is just kind of like opening the door. So we're going to certainly address all of this once. All these topics are going to come back like again and again, because the ontology gets revisited so much. So active inference being based upon the variational free energy as opposed to some other formulation. We're going to talk about this a lot more in chapter 2, And in equation 2.5, we're going to meet the variational free energy. And so leading up to equation 2.5 and in this discussion around 2.5 and in chapter 2 and elsewhere, we're going to talk about like, what do we mean by variational free energy and why is active inference using it? Essentially, it's a really tractable and optimizable heuristic that lets us carry out Bayesian inference efficiently. Because there's situations where if you had infinite computing resource, you could do exact Bayes. You could just plug and chug and just do the matrix multiplication and get the exact correct answer. However, with large data sets, that's not really tractable. And so in Bayesian statistics, and this is even outside and before active inference, people use variational methods because they're super effective computationally. So, for example, a variational autoencoder. A variational autoencoder is a widely used machine learning method or a Bayesian statistical method. And a variational autoencoder finds the optimal fit for data, not underfitting or overfitting, through finding the variational free energy. So in active inference, a lot of times there's a lot of interpretation and a lot of extension of what free energy is and all of this, but it's also possible to kind of pull back to this pretty non-contentious Bayesian statistical interpretation and just consider variational methods as being part of Bayesian statistics and used to tractably optimize challenging inference problems. So we're going to talk more about that in chapter 2. Anyone have a thought or a question on this? Ali, please.
I just wanted to point to the distinction between variational free energy and expected free energy, because as it says here, active inference is based upon the variation formulation. It's true, but the perceptual part of active inference theory is based on variational free energy. But when it comes to action, policy selection, and decision making, the parameter to be optimized is actually expected free energy, which is expressed in equation 2.6. So basically, those two equations between variational free energy expressed in equation 2.5 and expected free energy expressed in equation 2.6 can be seen as parallel to each other, but they're used to formulate different aspects of active inference. One is for perception and the other one is for action.
Awesome. Thank you, Ali. 2 ways to minimize free energy: update your mind through perception and learning, action through change in the world. The only thing you can't do is like put your thumb on the scale and directly change your sensory outcomes. So you prevent the thumb going on the scale because you don't have a line going from the internal states out to the sense states, so that the sense states are only coming in. That's the inbound dependency. And then that leaves 2 avenues for reducing free energy, perception, and action. And we're going to talk a lot more about this in chapter 2, when equation 2.5 and 2.6 come into play. Okay. Continuing on this theme of action. So action was brought up, and obviously, like, this is one of the really exciting pieces. This is what is going to be referenced throughout the book, a unified approach on perception and action, or all these different ways which we see active inference presented, like going beyond passive or perceptual inference. So does action have to change the world? Is this changing the physical environment, or can we change the generative model through action? Thank you, Holly.
Yeah, so maybe I'll just
yeah, please.
So I think when Ali brought up expected free energy, you're making changes to your policy, your brain, your model, and so then what's happening is that, and what I find interesting is the leverage points, this concept that making a very slight change your understanding of the world has a much larger effect than an actual, physical action. You can see it there in that image. So I thought, and I don't know if variational free energy and expected free energy really take that into account, that that these, the leverage points or not. I thought maybe some people have some ideas.
Cool. It's like in nested modeling, like for a generative model that only sees up to this point, the optimal leverage point that's detected is going to be so and so, but then a deeper generative model might be able to see more leverage points. Ollie?
Well, rather than describing action as something that changes the environment, if we want to talk a bit more precisely, what action means in active inference is actually one in which active states intervene causally in external dynamics, right? Formally, it means a kind of Jacobian coupling between the external states that depend upon the active states or active intervention. So, what we mean by changing the environment, we mean more precisely the kind of active state that would lead to a kind of causal intervention in the environment, and not something that just, I don't know, changes something per se. And this kind of distinction comes into play when we want to talk about covert and overt actions, as discussed in phenomenology, which we'll come to later in the book. But yeah, I think that would be helpful to keep.
Awesome. Yeah, so many things to look ahead to. Overt action is physically manifested, embodied action. Covert action or internal action is attention or mental action. And so that is like something that doesn't necessarily change outside of the generative model, but it's modeled with attention and action inside the model. And there's actually even a very cool recent work on transparent and explainable artificial intelligence. And again, just looking ahead, here they use attention and meta awareness as internal or covert attention generative models in an artificial intelligence way. But this model was actually developed in a meditation and phenomenology setting where the action selection was internal attentional control, not external control. Yeah, I'll put the this is the explainable AI paper in the chat. And then also just again looking ahead one place to what is this concept of action. This is figure 4.3, which is kind of like a Rosetta Stone figure. Pi are going to be the actions that are selected from. And where those actions intervene is how the hidden states of the world change through time. So if the hidden states S changing through time is like the true temperature in the room, and at each time point, T, you have a thermometer reading that gets emitted from the true temperature. So we're only able to observe the observables, which is the thermometer readings. And there's the true underlying changes in temperature. Or you could think of this as the true underlying activity of the neural system. And the observation is the fMRI. That's kind of where this comes from in terms of like Friston's lineage with SPM. And then if there's two actions you can take, turn on the heater or not, it causally intervenes in how states change through time. Maybe if you don't turn on the heater, it just passes the hidden state on forward without changing it. And if you do turn on the heater, it increases it by 1 per time step. So that's one sense of action. And then also just by mousing over, we see it from the ontology. And also we can update the ontology. It's never like these things are locked definitions, just to be clear. but we see a really common pattern, which is that there's like a broad and a narrow sense. A lot of these terms in the ActInf ontology, action, belief, attention, salience, things that people have brought up today, there's like a broad sense, qualitative definition, which largely or exactly is how we would use this day to day. Just action is what occurs. Super general term. And then there's like a narrow or a more technical definition, which sometimes conveys how this is operationalized in generative modeling. So more specifically, actions are the active states that the agent's generative model is going to select and so that's like more of the quantitative and formal definition of action. And then we'll explore a lot about how is action selected, because that is the entire expected free energy imperative, is the selection of action, and how goal orientation, preference orientation, expectation orientation is embedded within action, despite there not being a reward function, as we might see in reward learning, reinforcement learning. We're going to have a different approach for adaptive and flexible behavior that's not based upon reward learning or a reward function. Okay. Any other thoughts or just any other ideas on this in action? Martin?
So does action have to have movement? It's one thing I'm looking at here. I mean, the overt versus the covert. So overall, obviously, I have to have some movement that I could observe. But you said earlier that you could have the covert, like for example, attention being a covert action.
Yeah, well, depending on the system of interest, action could be an API call. So certainly it doesn't have to be a person's body that we're modeling. It could be a computational or a purely informational system. And then covert or internal attention, I mean, you could argue it has some physical informational substrate. So it's not like it's happening in some alternative plane of existence. But for the purposes of the modeling, it might not be realized through gross morphological movement.
Yep. Thanks.
Yeah, and it's going to be super cool, like how we're going to, when we look at figure 4.3 as kind of this cognitive kernel or this kind of firmware element. And then again, when we take it to when we look at how these models compose, even just starting to see familiarity here in figure 2, we see basically this figure 4.3, downward facing E, that's the inference part, hidden state and observations, and policy intervening. That's like this, downward facing E, policy intervening. And then that just gets nested. And so that speaks to the composability of these kinds of Bayesian graphs. And then when you look at a specific model, it becomes clear which actions are associated with overt movement and which actions are associated with covert attention. Okay, any other thoughts or questions?
Yeah, I guess just to briefly kind of add to the table under action, like on page 10, ever so briefly, the authors make the distinction between exploration and exploitation. And that seems like a really interesting or useful division to me. Like, so both of them are related to minimizing free energy or expected free energy in this context. And yeah, exploration is to resolve uncertainty. So I view that as like taking in new information versus exploitation, which has to do more with yeah, acting on the world to bring your observations into line with whatever your goal is, or your plan is, your set point, to use that word from cybernetics. Yeah.
Thank you. And here's a really clear claim. In contrast with other frameworks, policy selection, so behavioral selection, in active inference automatically balances exploration and exploitation. Now, this is a very strong version of the claim, as we'll explore. It's not that simply making an active inference model does automatically balance it. It's not like just writing it out is going to make, you know, the startup work and the ship work and the plane fly and all of this. So it can be read too strongly. It's not that it's automatically going to be effective. However, it sets the stage, or it provides an accounting system for the adaptive finessing between exploration and exploitation. And we'll explore that more in chapter 2. When we look at what is it that expected free energy and variational free energy are, and then how is it that policies are selected, behaviors are selected that are able to adaptively finesse between more exploratory behavior when there's information to learn and more exploitative behavior when there's kind of pragmatic value on the table, and maybe it's more important to just get the pragmatic value rather than to continue learning. But that's where we see variation in behavior, ultimately variation in cognition and behavior, when there's too much attention paid to epistemic or to pragmatic value. And that's a lot of where like these like precision psychiatry, cognitive modeling things come into play. And it even yeah. Any other thoughts or questions on this? It kind of connects to even the next point that was on salience. So salience, again, just as it is in the ontology, not that it's the only or the final definition, but it's just the extent to which a cue is going to be attended to. A cue that is not salient has no attention to it, and something that's not being attended to, the consequences for the cue are diminished. In the limit case, if you didn't pay attention to something, it just, you know, didn't cross your radar, it doesn't update the generative model. That's like attention to 0. In the other extreme case, when the attention is super high, it's like you're updating your prior to just whatever it is the new data point is. You perfectly attend to it, and it is like it's same as having like no memory. So no attention is like totally pushing your prior forward, full memory. Full attention, no memory. And then finding out what is an adaptive amount of remembering and learning and forgetting. Salient observations are those that resolve uncertainty. That's the information that we're seeking out, is the information that reduces our uncertainty about something. And then how much it reduces it, we're going to talk about some formalisms, especially in chapter 2, for comparing, like, is this sequence of observations or that sequence of observations going to be more salient? Which one is going to have higher epistemic value? Which one is going to reduce my uncertainty more? Which one will I learn more by viewing? Which one will update my priors more? Which one should I pay attention to more? Those are all kind of like related questions for like which information is going to be the good information. And these are the two sides of the joint imperative for expected free energy: information gain and pragmatic value. Epistemic value, how good is the information? Pragmatic value, what is the utility? Am I going to be at homeostasis? Exploration, exploitation. And so expected free energy is like this unified imperative that contains both of those elements, such that different policies can be ranked or evaluated or upweighted based upon how well they contribute to both information gain and pragmatic value. Comes up in chapter 2, but just wanted to kind of preview it. Any other thoughts or questions? Or let's go to the questions table and just like the questions that people are most interested in. Okay, first I'm going to go to the chapter 4 or cohort 4 questions. So just to make sure that even if they have few upvotes, that all of your questions can be addressed. So we'll first look at this question, and then we'll turn to chapter 1 questions overall. So as always, like, whenever you're watching or participating, even if it's a chapter that was long discussed ago or, up ahead, just add questions. It's really awesome, and upvote them so that we and develop the discourse so we can have good short answers for these. Okay. Page 9. Action minimizes free energy and surprise by changing the world. Okay, so we talked a little bit about that previously. Does this imply that the agent implements action to alter their world, or that action is implemented to change the agent's model of the world, or both? Can an agent implement action not solely to minimize their free energy, but free energy in another agent, for example, using action demonstration for observational learning? Does anyone have any thoughts on this? Okay, just starting with the observational learning. Two quick angles. So this, again, everyone can add more. In livestream 53 sequence, there were some paleoanthropologists, and we discussed observation learning a lot. And they highlighted how a lot of times people have focused on the kind of moment of innovation, for example, in creating stone tools in human cultures and history. But it's not just about the one innovator making the stone tool. It's actually in the moment of observational learning when the onlooker is able to either understand or not understand, and ultimately adopt or not adopt, or to copy or not to copy that behavior. And so they approach this from an active inference perspective. And this also brings up ideas like thinking through other minds, TTOM, which is kind of like the ActInf version of theory of mind. But thinking through other minds or thinking with other minds is more explicitly like one's generative model in a social environment also includes a generative model of what the other is thinking and doing. And so if one is in an encultured setting where action demonstration can be used for observational learning, then these are the kinds of dynamics that are possible to model. So that's one angle, is yes, it's been considered in a social encultured setting, how like gesture and demonstration and observation might play a role in transfer learning. A more technical and general response is in multi-agent systems, you have agent reducing their own free energy, making their own perception action cycle, but also you have like the joint distribution. You have the nestmate going about their own way, but then in the aligned or the healthiest or adaptive setting, the colony is also reducing its expected free energy. So one agent or neuron or a nestmate or a person might undertake an action that increases their own surprise transiently as part of a distributed cognitive system. that has a joint free energy that is reduced through that action. So it's not necessarily like every single subunit is always and only reducing its free energy per se, but the adaptive whole is going to reduce its free energy, and that might be entailing some subunit increasing its surprise. Yes, Younghun, and then anyone else.
Yeah, I mean, I think I keep thinking in a way as a psychiatrist, so it feels like psychoanalytic therapy itself is something a therapist doing, trying to minimize the free energy of the client, because like they provide explanations and interpretations about why they are doing such behavior or why they are making such relationships with others. So I guess maybe in a broad aspect, I would say providing explanations about why some individuals are behaving in such way would be another action that actually reduces the free energy of another agent.
That's very cool. Yeah, like by providing a narrative summary, it's a sense-making tool that helps explain and make sense of their perceptions and actions. Martin?
Yeah, it's really interesting. And thanks for that. It just got me thinking. You know, sometimes we I guess we try to minimize energy in others directly. Like I'm a university teacher, so by teaching, I'm trying to reduce, you know, their free energy. But sometimes you find it's best to let them find their own way. So I'm just thinking about like in psychoanalytics, which is a very distant field from my area, but letting others interpret meaning from their situation rather than framing it for them, if that makes sense. And I'm just thinking, you know, maybe this is a side topic, but would active inference speak to what's a better approach for one to do it for the other, or to let the other explore in a way, let them work through that space of energy, free energy, and then find their own way to minimize that?
Yeah, great topics.
Oh yeah, I mean,
Young-hoon.
I think that's a really good point, because like in psychoanalysis, we sometimes like have to choose whether to give a very direct interpretation, or sometimes we let the patient to understand what's going on by themselves. But it's always a controversial question about what to do. Well, we do have some like theories and some sense about like what to do on certain situations, but it's quite a pity that we don't really have like a very scientific grounds for what to do in psychoanalysis. So I think that's a really good point.
And the other thing that's just come to mind is this came up with this chapter, in fact, is so if we're working to minimize our free energy, right, and we sort of acting in a world to minimize surprise, how do we avoid confirmatory bias? You know, so I'm thinking now that the world is flat, so I am going to reinforce that model, because if I don't, then that's going to create some free energy, right? It's going to create surprise. So I'm going to act in the world. I'm going to hang out with people who don't challenge that. And I'm thinking back into psychiatry practice or counseling, maybe. People may have ingrained sort of models, and they're perceiving the world just based on that model, resulting in confirmatory bias.
Yeah, this is a very important topic, especially as they put it, existential imperative is self-evidencing. To repeatedly remeasure my body at homeostatic temperature, to be unsurprised about remeasuring myself at homeostatic temperature, is to maintain homeostasis. So in reward learning, you would say, well, homeostatic temperatures are the most rewarding. That's the top of the reward function. And then we're going to basically hill climb to get to the most rewarding body temperature. That's the reward learning paradigm. In ActInf, your preferences, your expectations, the C vector, is what you expect. I expect to find myself at body temperature. That's the bottom of the bowl. I'd be the least surprised at 37C, and I'd get more surprised as I went out. And now we're going to go to the bottom of the bowl, and we're going to pursue the most likely course of action, bound our surprise with expected and variational free energy. And so with the imperative as self-evidencing and surprisal bounding, we're going to pursue likely paths of action rather than with the imperative being reward learning. The imperative is to maximize reward. However, does self-evidencing mean that we seek out homophily? Does it mean that we just shut our eyes and go into the dark room? These are really important topics. And for example, in the dark room problem, it has been discussed for many years. People say, well, if the imperative of the generative model is to reduce surprise, then why don't people just go into sensory deprivation where there's highly predictable sensory inputs? And this has been discussed and addressed for a long time. But the short answer is, while you're in the room, reducing your uncertainty about your visual field, you're increasing your uncertainty about a variety of other aspects that are required for operation of the organism. And so you kind of net on balance, uncertainty is rising while you're in the room, which is why we are always adaptively moving around and seeking information and all of this. However, you can always set up a constrained or a toy generative model that exhibits any given limitation or pathology. That's not too surprising itself. But to actually use this as an accounting system for the kinds of adaptive and interesting behavior that organisms do exhibit, that's the interesting piece, not whether you can make a visual input only generative model that may select to be in a dark room. But if you have an active visual entity that can turn on a light, it may turn on the light. Or if it has a hunger cue, it may need to seek food eventually. So it's a little bit of a non sequitur, a kind of overinterpretation of a thought experiment that's just really in a little bit of a partial way trying to come at this. So you can imagine that there's situations where self-evidencing goes right and where it goes wrong. And that's exactly the space that we're exploring.
A lot of times when I think about homeostasis and temperature, I think about, like Huberman and many kind of biohackers want you to, experience cold contrast therapy. And especially if you are sensitive to cold, it's very important that you get in there and do your cold plunge, your cold showers. And so I think that's an interesting example where you're changing that, that set point basically by doing other activities that seem opposite to what would make you comfortable.
Cool, thank you. Okay. Any other thoughts or questions, or let's look at like one or a few of these asked questions.
Just a general question, Daniel. So when we post questions, because I posted that one, I had to go to the main table to post a question, and then it feeds into the cohort 4. Is that how it works? I couldn't post directly into there. Yeah.
All the it's all, there's only one underlying questions object. So each of these are like different views. So if you just go here and just like hit enter, you'll add a new row and you can ask a question in cohort 4. Yeah. And then that'll be like in chapter 1 and in cohort 4. Yeah. And so that it'll come up when we go to chapter 1 questions as well. Or you could
Go the other way.
yeah, or you could ask but then it might not necessarily be tagged to cohort 4.
Okay.
But it doesn't really matter what cohort you know, as long as it's in the chapter, that's a good place.
Got it. Thanks.
Cool. Well, one distinction, and you know, I look forward to seeing some of you next week in the other time, also discussing chapter 1, or next week at this time, where we'll be in chapter 6 with cohort 4. You're all welcome to join. But a really key distinction that's raised in figure 1.2 is the high road and the low road. And this is basically going to structure chapters 2 and 3. The low road is going to describe how. The low road is basically Bayesian statistics. That's how we're going to do cognitive modeling. But you could use Bayesian statistics to model anything. You could do it on health records. You could do it on weather data. So Bayesian modeling doesn't have to be about adaptive, cybernetic, autopoietic agents. Bayesian statistics, the how can be about anything. Chapter 2, low road. Chapter 3 is going to be the high road. And the high road is like the kind of what or why, and it's self-organized, self-evidencing systems. And so this describes more like the specifications for adaptive agents. This is like what they need to be doing to be observed repeatedly by an observer and or by themselves in this kind of like sophisticated reflexive sense. But it doesn't necessarily say how that happens. It turns out where the why and the how meet is active inference. We're going to be using Bayesian statistics, that's how, to model adaptive cybernetic entities, that's why. And so that's kind of going to be explored in the chapters 2 and 3, low road, high road. So that's kind of the big structuring motif ultimately of this textbook. Olivier?
Yeah, in the figure there is an order, you know, in all the items on the low road and the high road. Is the order important to understand anything, or just, you know, one group and another group?
It's a schematic ordering. I believe that there is a way to read them in order, but it's not an exhaustive or a unique ordering. So so for example, sorry, someone closing the okay. So Bayes' theorem is just describing basically tautological statements about conditional and joint probabilities. This gets used in a generative model, which is basically a model that can be used in a recognition capacity or in a generative capacity. That's the tale of two densities. In simple settings or passive settings, we're interested in perception as inference. But once we go into the anticipatory or the predictive setting, we're interested not just in dealing with incoming streaming data, but basically making ongoing predictions, nowcasting. The next kind of into the unknown step that nowcasting can take is action as inference, because it's not enough to just deal with incoming streams of data. Sometimes you want to take the action to open the book to find out. That idea of perception and planning as inference is unified in the Bayesian brain. And it turns out that variational Bayesian methods are going to give us some tractable, optimizable approaches for approximate Bayesian computation, where exact Bayes probably doesn't apply, or is really challenging, just like we kind of mentioned earlier. So that gets us to doing variational Bayesian optimization on perception and planning as inference in the Bayesian brain, that's active inference. So that's kind of low road ordering. The high road ordering is starting with the free energy principle, which is a non-falsifiable principle, just like the principle of least action in classical mechanics. This is like a principle for informational systems. And systems under this principle are seen as being in the game of self-organization via surprise minimization. You'll continue to find yourself organized if you're continually minimizing your surprise about who and what you are. That is supported or described by a partitioning, conditional independent structure called a Markov blanket, which we're going to explore. And the Markov blanket can be seen as carrying out self-evidencing through this kind of anticipatory real-time predictive processing, which is related to predictive coding. And in the extended, embedded, inactive setting, that can be understood as basically self-authoring, self-meaning making, and ultimately even extended niche construction, which gets us to active inference from the high road. So again, not exhaustive or unique ordering, but certainly something that they have considered and laid out a certain way. Thank you, everyone, for this awesome chapter 1 discussion. I hope to see you either next week at the other time or whenever. And just leave a comment on this page here if you want to start up the math group. So thank you all.
Thank you.
Thank you.
Bye.